Hello everybody. In today's class, I'll discuss about the data processing using R programming. We'll generate data using R in a randomized fashion and then use different tools and techniques in R to process that data and generate results. So in this process, I'll use the libraries like dplyr, uh, tidyverse, ggplot2, which is used for graphics uh, or graph drawing purpose, string R for string processing purpose, and few more additional libraries that we'll use whenever we need it. So to start with, uh, uh, let's open the R console, and first uh, I am just uh, using the library comments so that these libraries are imported. So one is tidyverse, the next one is uh, ggplot2, so as you see there are some other libraries including reader, stringer, table, tdr, forcats, lubridate, par. They have already imported. So uh, for the safe side I'll also use dplyr here, and now I try to generate some random data. To do this I'll set the seed first. This will be the seed to the random data generation process, and then I'll use some sequence of dates. So to do this I'll uh, write date sequence. I'll generate a sequence of dates over 365 days. I'll generate a sequence of dates uh, and it will be of length 365 uh, to create data for an entire year. So I write uh, date sequence as dot date, then I give a start date, say 2023/01/01, then increment by day, and then provide a length of 365. Okay, so I generate a date sequence now. So this will be a list of 365 days in a year, and then I create the data. Say I create the sales data uh, for three different product categories. So then I'll create the data uh, in a form of data frame. So I say data dot frame, and then I write the date, uh, which I replicate three times. uh, Date dot that sequence I take, and then replicate it for three times. Okay, then I create category, uh, category. This I uh, replicate for 365 times. uh, A, B, C be the product categories here, we assume. So I generate 365 into 3, which is 1095 rows. So I now create the random sales data, which is basically sales. That is the name, and I say this is equal to round. Uh, we generate using uniform distribution. So I'll say R uniform. Uh, we have to generate 1095 number of rows with minimum is equal to 500 in a day, and maximum equal to say 5000 in a day. Okay. This can be shown up to 2 digits. So I end this brace here, and then finally end the brace for data frame. So this is how I create the data. So data can be inspected in form of this. I said right, simply write head of data. So I see the top six rows with date, category, and cells. Okay. So now I should be able to remove the duplicates using a command like data, uh, and use the filter called distinct. So I use the operator here, and I use distinct here. So this will be eliminating all the duplicates. Okay, next, uh, suppose I want to trim the white spaces from character columns. So then I'll write data, reassigning to data, and do the operations like mutate. So across where is dot character comma str trim. So this step will help you to trim white space from character columns. So I apply this, and now I apply uh, data transformation. So suppose I want to create a new column like sales growth rate. So then I reassign the data from the data after processing like this. So I do something like arrange by the date, arrange by date, and then do a chain operation, uh, group them by category, group by uh, category, and then uh, perform an operation of uh, sales growth, sales growth, that is the new variable here. uh, so this is assigned to sales minus lag of sales. So this is divided by lag of sales multiplied by 100. So this will give me the percent sales growth over a category per day. So just let me do the matching of the braces. So there has to be one extra brace here. So I hope this is fine. So yes. So I now see the data, possibly just inspect the data using head. So then that means I'll get one additional column called sales growth, where first three categories A, B, C on day one shows uh, not applicable, and then it is showing based on the sales growth rate. Okay, so I have created a new column called sales growth. Okay, so now suppose uh, I want to check whether there is very high sales for some day, which is uh, probably some improper data, so incorrect data I can find. So I'll create a flag for high sales. So, so I say threshold, say quantile, data, take cells from data. Cells is the capital letter. So, and create the threshold. So this is my threshold here, and now create a new variable. So data muted. So I'll mutate this data to create a new column called high sales. which is defined as if else cells greater than the threshold. Okay, then yes, then else no. Okay. So let me match the closing brace here. So now inspect this data. So I have a new column calling high cells, and it has no ES and so on. ES denotes is above 75 percentile. So now we can do some aggregation. So to do the aggregation, we can create a summary data. So for example, I can say cell summary. This can be achieved by applying a filter like this. Then group by we'll group it by category. So to do this, I say category here, and then I'll use summarize after applying this filter. I'll apply the filter percent arrow percent and then say summarize by total cells. Total cells is sum of the cells so if I write na dot rm equal to true, this will eliminate all unavailable or not applicable data from the cells column if it is there. So the summing process will not fail. So I copy this. So this is meant for total cells. So once total cells is computed, I'll also compute the average cells, which will be the mean of the cells, and then maximum of cells, which can be computed using max function, and also uh, this is max cells. So I change to this to max and this one to average max cells, and then mean cells will be this is mean of this. So once I compute this, I get the cell summary. So what is this cell summary? Let me see. So it is giving total cells, average cells, max sales and min sales per category. Okay. So as you see, average sales is 2744 and max sales is 4997 and mean sales is at 503 etc., which is very much within range uh, of uh, the selected range what we have taken for uniform distribution, that is having the minimum of 500 and maximum of 5000. So now we can compute the monthly sales trend, and to do this uh, I can compute the monthly sales data. Monthly sales, this variable can be assigned to data uh, and summarize for sorry, summarize can take afterwards. You can first apply mutate. We'll first do the mutate mean for month. Month needs to be recalculate based on the date. So I'll do uh, floor date, then date, comma month. So this will take the date and extract the month. Okay. So once I do this, I'll apply one more filter. Then group by month. And this will follow the summarize operation. So we'll summarize based on the total sales. Where total sales is sum of sales and while doing that we must eliminate the NAs. So NA dot RM equal to true. So this will do the sum operation for total sales based on the month after extracting the month. So I hope this will be fine for monthly sale. So monthly sale, if I see now what is monthly sale, we, we get a total sales data and the trend analysis for the entire month is generated. So now we can do some statistical analysis. For example, I can do some correlation computation between sales and growth. To do that, I can say correlation core of, that is the function core of data sales, data dollar sales will give me the sales data directly, and then extract the sales growth as well. and use complete observations. So we'll say complete dot obs. Okay. So this gives me the correlation. So what is the value of correlation now? So there is a correlation of 0.511. Okay. So I can say print the correlation data. So correlation between cells and cells growth, between cells and cells growth. So this can be written as a round of correlation 2, correlation comma 2, which means that rounded up to 2 digits. So this will be printing 0.51. Okay. So now I can do some basic regression on analysis. So to do this, I can do uh, draw a regression model. So to do this, I use lm command between cells and cells growth. So I'll say cells with cells growth. Okay. And that will be based on the data. And finally, I'll write the summary of a range model that will give me a complete information about the uh, linear regression plot. So it is giving me the coefficients, this. So if we just look into the entire result, we see the residuals, and then getting the coefficients, the intercept, okay, the standard errors, and the t-values. Okay. So as you see that adjusted r square is 0.26, okay, and p-value less than 2.2 into 10 to the power minus 16. Okay. So now what we do is uh, we can also print some summary statistics. To do this, I can say that uh, summary stats uh, is data percent arrow percent, then summarize uh, first you get mean cells, which is means of cells. Mean cells is mean of the entire cells data with na dot rm equal to true. Okay. And then also compute the median cells. So I'll copy the entire thing of mean cells here. Okay. And I write it for median cells. So instead of mean, I'll use the function median here. The rest remaining same. I'll also compute the standard deviation. So I'll say SD cells, and I'll compute the standard deviation here. Okay, and as I should also be able to compute the range, which is the max and uh, max minus mean, which is uh, represented as the difference between the max and mean. Okay, so I can say cells range. So I just copy this and say max of cells minus mean of cells. Okay, and it is assigned to cells range. So I say cells range equal to max cells na dot rm equal to true minus mean cells na dot rm equal to true. So here it ends. So I just compute this and then I print the summary stats. So let me see what is the summary statistics here. Summary stats. So I get the mean cells, median cells, standard deviation of cells, and a range of cells uh, for each category A, B, and C. Okay.